Okay, in this video, we're going to show how important return air is to an AC system. Regardless of how efficient your system is, if the return air is not set up properly, you will not be receiving the efficiency your system can put out, and you'll be wasting money. Right now, I'd like to show you the display unit. This is a 3-ton outdoor unit. This is a typical 3-ton upflow gas furnace. This is a 3-ton evaporator coil. This up here is the supply plenum where the air comes out. And these right here are the ducts that normally would go to your registers. But right now we have them going to this instrument called a flow hood. And what this flow hood does, it measures CFMs, or it will measure all the air that this unit is putting out. Right here is the return air or intake that we've equipped with 3 different size openings. We've got a 12-inch, a 14-inch, and an 18-inch. Now on a normal 3-ton house in Houston, you have only a 14-inch opening on a return air. Now this over here is a instrument called a magnet-helix gauge. And what this gauge does is it reads static pressure in a duct system. Now static pressure is the pressure in a duct system, in the system when the fan is operating. Now as you can see, we have a pointer at 0.1, and this is the ideal static pressure of the return air. Now what we're going to do now is we're going to go ahead and turn the fan on and open the smallest opening of the return air, and then we're going to read our readings. Okay, so we're going to go ahead and turn the fan on. I've got the 12-inch open, and then what we'll do is we'll read our static pressure readings as soon as it comes on. Now as you can see on the magnet-helix gauge, we are reading a 0.4 on the return air static pressure. It's very high. Now we'll go ahead and check the flow hood and see how many CFMs are coming out of the unit with the 12-inch opening. As you can see right now, we're pulling out about, average about 1080, 1070. So 1060, 1070 CFMs. Okay, so right now it's not operating very efficiently at all. What we're going to do right now is going to go ahead and close the 12-inch and open the 14-inch and check our readings again. Now with the 14-inch open return air, our magnet-helix gauge went down to almost 0.3, which is better, but it's still too high. And our CFM reading, let's see if it went up. It went up to 1120. So as you can see, the more return air you have going in, the more supply you have coming out. So at this point, let's go ahead and close the 14 and open up the 18-inch return air. Now we'll check our magnet-helix readings. As you can see, it has gone down to a little below 2, which is a lot better, but it's still not 100% efficient. Now let's go ahead and check our airflow reading. We are receiving about 1170, 1160, so it's gone up again. But let's go, and remember what I told you, a 3-ton house typically only has a 14-inch return air. So let's go ahead and open up the 14 and the 18 and check our readings. Now with the 14 and the 18, you can see the magnet-helix gauge. There you go. Ideal static pressure for your return air. That is where you want to be. Now your system's going to be running 100% efficiently. Let's go ahead and check our airflow reading. As you can see, it's gone up to almost 1200 CFMs. Now, as you can see, between the smallest opening to the largest opening, we lost around 160 CFMs. Now, I've got a chart over here that will show us what that means to you in dollars and cents. Now, this is a 3-ton system, which equals 36,000 BTUs, and has 1200 CFMs of air, as you can see with the largest opening. This unit will take care of about a 1,700 square foot house, and the electric bill on this house should be around $170. Now, as you've seen, we lost 160 CFMs. Now that is equal to 4,759 BTUs per hour, or 71,389 BTUs in a 15-hour cooling day. Now, as a homeowner, you've just wasted 2 hours of the system running constantly for 2 hours. Now, that could be on your light bill. That could be $100 to $200 extra on your light bill, depending on what your kilowatt, what you're paying for your kilowatts. Now, just to give you another example, the 160 CFMs that we lost could cool a large master bedroom, just to give you indication what you're losing. Now, as you can see, regardless of how efficient your system is or what brand it is, if your return air is not set up properly, you're wasting money.